Hello, calculus fans. Let's try the function f of xy equals xy squared over x squared plus y to the fourth. And now let's ask if this limit exists as xy approaches 0, 0. Now, because of what we saw in the previous problem, let's try to look at the limit along any non-vertical line through the origin. Let's approach along the line y equals mx. So m is the slope of the line that we're going to approach along. If we plug in y equals mx, then we get an expression that looks like this. M squared x over 1 plus m to the fourth x squared. You should work through the algebra, make sure that it all works out. So, as xy approaches 0, 0 along this line, we're going to get a limit of 0. You should be able to see that because there's an x up here in the numerator. As x goes to 0, then this whole thing is going to go to 0. And we have a 1 in the denominator that prevents the denominator from going to 0. So, we have the same limiting value along every non-vertical line through the origin. This still does not prove that the limit exists. Now, here's a trick. Let's approach along a curve, not just a line, and specifically we'll approach along this parabola, x equals y squared. Now, if we plug that in, we get a half. So we're getting a different value now. So that tells us that f of xy approaches a half as xy approaches 0, 0, specifically along the path x equals y squared. So, different paths lead to different limits. This limit does not exist. But this required some creativity in coming up with this different sort of path. Instead of approaching along a straight line, we approach along this curve and we get something different. Okay, that's all for now.